So, as far as stats goes, stats courses are not like any course you have ever taken before. They're not like traditional math classes, okay? By that I mean that the process that you're going to use is more important than the actual numbers that are involved, okay? It's more about what the numbers mean as opposed to how to calculate the numbers, which is the case in most algebra, geometry, calculus. All those heavy-duty math classes are more about the computations than it is about what the computations actually mean. With statistics, it's all word problems, which is why people are terrified of it. Okay? It's not too bad because it all follows a basic rhythm. There is a basic language to it. Okay? They use all kinds of odd symbols to make it so really easy procedures look really, really complex. We'll be getting into the different ways of writing out a average or a mean, okay? And you can write that 15 ways from Sunday and make it look even more complicated the more you try and the more you write it out. It just can look crazy. It's insane. Okay, it's all about job security. Let's make this really easy thing look really, really hard. All right. They also will use all kinds of symbols, and I already said that, but it's what they make editing for. All right. The other thing is that, well, stats don't lie. The people that lie with stats are the ones that don't understand how to use it. Or they know how to use it and they're manipulating you intentionally and they're liars. So that's why they're using it to lie. Okay? The key thing with stats that people don't quite understand is it's a little bit of everything. It's a little bit of computer programming, a little bit of logic, a little bit of Greek, a little bit of psychology, a little bit of math, a little bit of science. It's a little bit of everything just thrown together in this mixing pot, and out comes out stats. Okay? Stats is the key, the basic, most simple definition of statistics I can give you is that stats is a study of data. It's all about collecting data, organizing data, summarizing data, analyzing data, interpreting the data. It's the study of data. All right? So with no further ado, let's go right on into the material we're talking about. Again, stats courses are not like traditional math courses. You will have vocabulary you have to learn. Let's start off with that right away and go from there. As far as the first terms we're going to be talking about, those are going to be the levels of measurement. Okay? Simply put, the levels of measurement are different ways that you can categorize things. Data. Okay? You're trying, with the levels of measurement, you're trying to figure out what grouping to put the data in. Okay? Because the grouping that you're basing your data on will change your formulas. So you have two overall types. You've got qualitative and quantitative data. For qualitative data, that means that you're talking about primarily word-based, okay? It doesn't have a measurement. They're countable. They're not measurable, okay? Then you've got quantitative data. Quantitative data is numerical. It's straight up numbers. It's measurements, okay? The key difference between qualitative and qualitative doesn't use measurements. It's just counting. You're saying, oh, there's 52 of these people. There's 27 of those groupings, okay? For quantitative, that's the numbers, okay? You're talking measurements. You're talking 54 inches. You're talking 27,000 degrees, whatever it may be. Okay? And beyond that, you can break them up further. For your qualitative data, you can break them up into two categories. First one is your nominal. The next one you've got is your ordinal. For nominal, these are just names. You can't really put them in any order, all right, without making someone really upset. You've got ABC order. You've got basic numerical, nothing crazy, no measurements, no way of saying, oh, this one's going to be bigger than that one. Okay? Whereas for ordinal data, you've got small, medium, large. You've got the different sizes it could be. It can go from tiny to huge, right? It all depends. All right? For ordinal, that you can put it in an order, but there's no set amount that a large is. So if you're talking trying to figure out whether a coffee size is large. You could have a 16 ounce be a large, and you can have a 64 ounce be a large. It all depends on what they consider, what the particular manufacturer considers large. Okay? And that's where ordinal comes in, because there's no set absolute measurement to it. You're just generalizing. Okay? The next two levels you've got are based on quantitative data. These are your measurements, okay? And the key with these is, can your values be negative, okay? If your measurements can have a negative number, right, that means your data is going to be an interval, okay? The term they use for that is interval measurements, okay? If your data values cannot be negative, if there is no natural starting point, then you're going to say that your data is a ratio level of measurement. Okay, it's not a ratio, it's at the ratio level of measurement. Some examples. If you were to go around and ask someone what their favorite ride at Disney World was, all right, they say they're the teacups, they're the roller coaster, there's the rock and roller coaster, the Space Mountain, Small World, whatever it may be, whatever they say their favorite ride is. If you were going to try and figure out which level of measurement that would be, I'd be looking at my little flow chart that you've got, and I'd be saying, oh, my data can't really be arranged in a measurable order. You can't say that a roller coaster is better than the teacups, because they're both going to make you puke. They both can make you sick. It's not like you can say one is better than the other just based on the fact that you've got a word. Okay? So I would go with nominal as far as that grouping goes. All right. Now, if, on the other hand, you were asking people where they prefer to sit, you've got the front, the back, you got the middle, you got the third car, the fourth car. You can't really measure that and say, oh, everybody who likes to sit in the front is better than everybody who sits in the back. Because if you tell that to someone, they're going to get really frustrated, right? You can put them in an order, but you can't say that every single car, every single ride is going to have the same exact amount of seats, because it doesn't work that way. All right? Not as a universal concept for every single ride. Okay? So for that one, I'd say it's qualitative because it's a word. We're just talking about middle, front, back. There's no measurement to it. All right? And then I'd be going, all right, so it's not nominal because I can put it in an order. I can say that the front is going to be closer to where the action is as opposed to the back in most cases. Right? So then I would go with ordinal in that case, all right? If on the next level, if you were asking people how tall they had to be for a particular ride, whatever ride it may be, all right? They say we're going to look at them, and they're looking at them, and they're going, I want to go on Space Mountain, and you have to be insert inches here. I'm not sure what they are off the top of my head, all right? So you've got a height requirement. The questions you've got to ask for yourself right there, you can go through the full list. Can the data be put into a measurable order? Absolutely, right? Do the differences between the categories mean anything? Is there a measurable difference between 42 inches and 43 inches? Absolutely. The big question you've got is, can you be a negative inches tall? All right, because we're talking height. Can you be a negative 5 inches tall? Is there a natural starting point? Absolutely there is. You can't be negative 0 inches tall, negative 5 inches tall. It just doesn't work that way. You're going in one direction or the other, right? So we're going to say that, no, our data can't be put, you can't have a negative number, so there is a natural starting point, so we have a ratio level of measurement for your height requirements, okay? The last example would be, what outdoor temperature is too hot for you to wait in line? Right? So if you've got that line that's 5 miles long, it's going to take 4 hours, and you're going, it's too hot. What is the hottest that you're willing to put up with? Okay? So, or the coldest for that matter. Either way. Looking at your list, your data can be arranged, put into a measurable order. All right? 15 degrees is a lot colder than 90 degrees. And 90 degrees is hotter than 50 degrees. All right, you've got that measurable setup. The differences do mean something, right? You can say that, well, 90 degrees is a whole heck of a lot hotter, and there's an actual measurable amount than 15 degrees. All right. And then you've got the negative numbers. This is where the big thing comes in. You ask yourself, can I have a negative outside temperature? And absolutely, you can have -4 Fahrenheit. And I doubt it's going to happen in Disney World. But hey, global warming, whatever it may be, climate shifts, it can happen. Okay, so because it's a temperature, yes, it could be interval. That would make it, because it could have a negative number, it makes it an interval level of measurement. Okay, the next setup we've got are your statistics versus parameters. Okay, for these terms, basically, a statistic is something that is a piece of data that comes from a sample. All right. Now, a sample is just a group that doesn't have you don't waste the time that it takes to ask every single person who's ever been to insert ride here if they enjoyed it. Okay. Most of the time when you're writing that, you're writing it in Latin, aka regular English. Okay. For the parameter side, that's the population. That's the entire group of everybody who's in that category, who's ever been on that ride, it's the entire group. It's your census. Okay? With this, your parameters are your population data. Now, your population data has every single value you could ever want and is written in Greek most of the time. There are a couple situations where the differences between the sample and the population are Greek versus English. There are 1 or 2 spots where it doesn't fall, but if you're not 100%, most of the time your population info will be written in Greek. Okay, as far as getting your sample goes, there are a couple ways, all right? There are 5 common ways of getting your data points, okay, of getting your data. You've got the first one, random sampling. That's where you're picking numbers out of a hat at random and everybody's got an equal chance. Say you pull a number, hey, it's number 52. Who's got number 52? And you pull them and you use them as your sample. You ask them whatever question it may be. All right, now, random sampling can be broken down again into a level called simple random sampling. For simple random sampling, you're taking the number out. Oh, hey, I got number 52. And then once you've read it off, you put it back in the hat so they still have another chance of getting picked again. All right? So basically the thing with random sampling, if it's got the word random sampling in there, you're picking it out of a hat. You're picking it at random. There is an equal chance for everybody. There is no bias. Okay? The next level you've got is cluster sampling. All right. For cluster sampling, what we're doing there is we're breaking people up into groups. All right. And we're picking everybody in a couple of those groups. So like if you're looking at the parking lots and we're looking to see what the certain people coming from certain parking lots, how long it takes them to get to the front of the park. All right. To walk in the doors. You look at Disney has it set up so you've got the heroes lot and you've got the villains lot. All right, so if you park in the Heroes parking lot, all your parking areas are labeled, your parking rows are labeled by Disney characters that are heroes. On the villain side, it's all on the villain side. It's all done with villains, okay? So, say you're looking and you're trying to figure out who to pick. You go through your list of people, you go through your people getting on the ride, on the tram, the ride to take the bus type of thing that brings you up to the front of the park, and you say, all right, everybody who parked in Simba, Mulan, Ursula, and Scar, I need to chat with you real quick. Give me 2 seconds to check out how long it took you to get from the front from your car to the front of the park, or whatever it may be. Okay. For cluster sampling, the key thing there is you're breaking up your full overall population into several smaller groups, and you're picking everybody in a couple of the groups. Okay. Then you've got stratified sampling. Now, for stratified sampling, all you're doing is you're breaking people up into 2 or more groups. So you've got your heroes and your villains again, all right? And you're picking just the same number basically from each group. So I'm going to take 5 families from who parked in the heroes lot, and 5 families who parked in the villains lot. So you've got a generalized idea of what you've got, and it's an even distribution of where you're pulling your people from. Okay. Next level you've got is the systematic sampling. For systematic sampling, you're looking at every blah data point, nth, all right? Every other person, every third person, every fourth person, every 15th person. So what you're doing is you're waiting there, you got 1, 2, 3, 4, 5 people go by. Then you ask them a question. Then you go 1, 2, 3, 4. Another 5 people go by, and you ask them, and then another 5, and then another 5, and then another 5, and then another 5, and you just pick that number. It can be 5, it can be 52, it can be 999,922, whatever. Some random large number. You can say that's my cutoff. Every time somebody with that number goes by, that's when I'm picking them. All right. The last level you've got are convenience sampling. For convenience sampling, you're picking who you think will answer your question, who's convenient, okay? There is some massive issues with this because you end up, when you use convenience sampling, your data tends to be skewed. You're already setting yourself up for failure. You're already setting yourself up for a bias, rephrase, not failure, okay? Basically, you're standing outside and you're going, oh, you'll answer my question. You're not intimidating. You might answer my question because you actually look like the people I'm looking to talk to. Okay? If you use this method, it's an easy way to mess up your data because you're going to end up having a lopsided data set. If you're looking for information on how much people enjoy the parks, if you look at people and they look grumpy, you're not going to talk to them because you don't care what they have to say. They're not going to help you. Unintentionally, or intentionally for that matter, you're going to end up conveniently picking people who happen to be within your specific realm of requirements. You don't want to use convenience sampling because it tends to lopside your information. You want to make sure that the people you're talking to or the groups that you're looking at actually match the overall groups. So if you're looking to figure out how bad crowds are in the morning and you only talk to people who show up at between 11 and 12, you're missing the people who showed up between 6, 7, 8, 9, 10, everybody before 11 o'clock. That's when most people show up. You're going to end up messing up your data set unintentionally. So you've got to be careful to make sure you've got every aspect included. Otherwise, your data is useless before you even started the analysis, before you started the number crunching. Okay, sampling is vital. Getting your information is vital. And these are things to watch out for. All right? Things to look at when you're looking at where the data came from. Look at your sources. Is the source objective? Is the person you're getting your information from, do they have some sort of a bias? If you're not careful of that, you're going to have issues when it comes to actually computing your data because it's going to be useless, right? Then there's the issue of statistical significance, all right? So for something to be statistically significant, that means that whatever it is going on can't happen, isn't likely to happen by chance. It's not randomly going to happen most of the time. You're going to, little more than most, you're talking 90% or more in most cases. For it to be statistically significant, you're looking for a lot more than 90%, all right? 95% of the time, it's not going to happen. For example, having the temperatures in Florida go down to negative 52 degrees. That's not going to happen by chance. There's going to be some freak weather occurrence. It's a random what's going on type of situation, right? For it to be statistically significant, it's got to be outside of that 90-something percentile. You want it to be way the heck out there where it's like, huh? Right? You want it to be that, wow, that's really not going to happen randomly. That's going to intentionally happen. Okay? For something to be practically significant, any changes that you're going to be making based upon this information has to be justified. It's got to be practical. So if you're going to think about a situation where you're on Weight Watchers, you're on a diet, right? If you're on a diet and you're saying, oh my goodness, statistically, this isn't going to happen by chance, and they find that statistically, say, 90% of the time, 90% of the people going on this diet, this random diet, lose a total of 5 pounds over a full year. Well, I'm not going to want to diet for a full year only to lose 5 pounds. I'm going to want to lose 20, 30, 40. If I'm going to be dieting and not eating my happy foods, my sugar, my sweets, my salts, my fats, right? My good, flavorful food, I'm going to want to have. I'm not going to want to put all that work. It's not practical to put all that work into it to lose 5 pounds, right? Statistically significant versus practically significant are two entirely different beasts, but they are intertwined. All right? For something to be statistically significant, it's got to be rare. For something to be practically significant, it's got to be rare, and it's got to be worth it. Worth the effort to be put in.